Right. Condition when EMF is greater than terminal voltage, E is equals to terminal voltage, E less than terminal voltage. E means EMF, V means terminal voltage. Now, what is EMF and what is terminal voltage? If this is battery, it supplies energy to the charge Q so that it can move in complete circuit. That means it starts from A, go to external resistance R, a wire है, and then come to battery and then come back to A. तो एक circuit पूरा complete cover किया. So work done to move unit charge in complete circuit once. Complete means if I start from A, go to B, go to C, go to D, come back to A. This is called complete circuit. And work done to move the charge only in external resistance is called terminal voltage. Terminal voltage. मतलब ये तो पॉइंट ए डी का बीच में से ये कनेक्शन निकाल दो तो खाली बैटरी बचेगा. तो इसका एंड का वोल्टेज को बोलते हैं टर्मिनल वोल्टेज और ये रेजिस्टेंस के एंड का वोल्टेज को हम लोग बोलते हैं टर्मिनल वोल्टेज. टर्मिनल मतलब एंड, तो ये दोनों एंड का वोल्टेज को बोलते हैं टर्मिनल और एकदम सिंपल में एक्सटर्नल वोल्टेज को टर्मिनल वोल्टेज. सो वी हैव टू एक्सप्लेन व्हेन दिस ईएमएफ is greater than terminal, when it is equal to terminal, when it is less than terminal. Heading you have written?
Yes, sir.
Yes, sir.
Yes. This is resistor R connected with battery of EMF E, whose internal resistance is R. It is supplying current I. Capital is V is voltage across external, small v is voltage across internal resistance. Consider a battery of EMF E having internal resistance, battery of EMF E having internal resistance small r, consider battery of EMF E having internal resistance small r supplying current to external resistance capital R, let capital B be terminal potential difference. Just wait once again. I had written heading condition, obtain condition when EMF is greater than terminal voltage, equal to voltage, less than terminal voltage. So consider a battery of EMF E having internal resistance R, supplying current I to external resistance capital R. Let V be the terminal potential difference. So can I say battery is giving voltage to external plus taking internal also small v? This line followed? Total battery voltage is given to external plus internal. Hello?
Yes, sir.
Yes, sir.
Okay. So this is nothing but I into capital R plus I into small r. By Ohm's law, V is IR. I common into R plus R. Therefore, I is E upon R plus R. I is voltage upon resistance is called Ohm's law. Hello?
Yes, sir.
So sometimes they can change the question and they will say, show that Ohm's law can be applied to complete circuit. तो आपको इधर तक लिख के लिखना है, this shows that Ohm's law is applied to complete circuit. अगर ऐसा पूछा तो just copy till this, then I'm explaining further. Simple है एकदम part. External resistance R का अंदर current is I, voltage is capital V, internal का voltage small v and current flowing through the circuit is I. Please copy till this. Which lecture you all have before this till what time? Hello? Before this, you have any lecture before this lecture?
No.
Yes, sir.
No, maths lecture somebody is having, no?
Yes, sir.
Yes, sir.
It starts at what time?
8:45.
8:45 to
10.
Sir,
8:45.
8:45 to 11.
Acha, same day, Monday, Wednesday, Friday.
Sir, we have
Yes, sir.
biology.
No, timing.
9 to sometimes takes till 11, sometimes 10:45.
So that means everybody is having starting from 8:45, na?
Sir, my maths lecture is from 7 to 9.
7 to 9 you have math lecture.
Yes, sir.
Who is saying this? I think Rajwardhan.
No, Swaraj.
Swaraj. Swaraj, you have till what to what time? 7 to 9.
Yes, sir.
7 to 9. And then 9 to 11 also you have.
No, sir.
Okay. ठीक है. Swaraj.
Done, sir.
Let everybody come till that.
Done, sir.
Everybody is done, na? Can I clear this from the screen?
Yes, sir.
Just wait for a moment now. Since E is V plus I into small r. Suppose I write 10 equals to 8 plus 2. Then can I say 10 is greater than 2 or not? Tell me that first. Can we say 10 greater than 8?
Yes, sir.
So if you write 6 is 4 plus 2, then can you say 6 is greater than 4?
Yes, sir.
Very good. So E is V plus something. So can I say that means E is greater than V?
Yes, sir.
This time battery is giving the current or taking the current or neither giving nor taking. Is the battery giving the current or taking the current, or neither giving nor taking?
Giving.
It is giving current
Giving.
I. Yes. Giving is charging or discharging?
Charging.
No, giving is
Charging.
नहीं,
Discharging.
discharging.
Discharging. This is.
दे रहे हैं ना तो discharge. So thus when battery is supplying the current, when battery is supplying the current, that is when it is discharging. This all words you have to remember. That is when it is discharging. Therefore, thus when battery is either supplying the current, that is when it is discharging, E is greater than V. So when the EMF will be greater, when battery is supplying the current or when it is discharging. So if they ask MCQ, battery is discharging or supplying current, then E equal to V, E less than V, E greater than V. What you will write? E greater than V. Okay, clear?
Yes, sir.
Yes, sir.
Copy 4 line further.
Done, sir.
Case 2. Since E is P plus I into R, thus when I equal to 0, that is when battery is neither supplying nor drawing. Supply matlab to give, drawing matlab to take. Thus when I is 0, that is when battery is neither supplying nor drawing the current, then E will become V, because I is 0, 0 into anything is 0. Okay,
Yes, sir.
1 minute more. Also, E is V plus IR if internal resistance R is 0, then what I will get?
E is equals to
E
V.
equal to V.
Equal to V. So E equal to V has got two conditions. Battery is not giving current nor taking. It is also called as open circuit. When I is 0, that is battery is neither supplying nor drawing the circuit, also called as open circuit. Then E equal to V. If internal resistance is 0, then also I can say E is V. Hello?
Yes, sir.
Yes, sir.
Practically it is not true because some resistance battery will have. But if it is ideal battery, no internal resistance, मतलब खुद कुछ नहीं खाएगा, सब बाहर वाले को देगा. So when internal zero resistance, then also we can say E equal to V ideally. Now write case 2 and A and B point. When I is 0, that is when battery is neither supplying nor drawing the current, also called as open circuit, then E equal to V. Done?
Yes, sir.
Everybody has done? Can I clear?
Yes, sir.
Case 3. This is a charger which is having variable resistance. Charger will charge the battery or take the current from battery.
Charge the battery.
Charge the battery.
Charger मतलब ये charge the battery मतलब ना current battery का अंदर जाएगा. It won't come out but it will go inside the battery. So whenever you see current is not coming out from positive but entering in positive, that condition is called battery is getting charged. So terminal voltage is V, variable resistance R. This is supplying current to the battery of EMF E, internal resistance R. Then see what happens. When battery is getting charged, then outside wala voltage V is taking care of battery plus uska internal resistance. So V is E plus I into R. That means E will be V minus IR. So can I say E is less than V?
Yes, sir.
Okay.
Yes, sir.
Thank you. Please draw the diagram and write.
Done.
Okay. One small note we'll write, then we'll see cells connected in series parallel. Since I equals to E upon R plus R, if its internal resistance R is 0, then can I say I will be maximum? Can we say? Hello, can we say that way?
Yes, sir.
Because denominator कम हो गया मतलब R एकदम कम से कम मतलब 0 हो गया, तो current will be maximum, that is E by R. Just write this note.
Done, sir.
Then write combination of cells. First, series combination. Series combination. Series combination. Series means one after another or one below another.
One after another.
One up.
That means it will be in single loop. It won't get divided, na? ऐसा divide
Yes,
नहीं
sir.
होता. So whenever same current flows through the circuit, then it is called series combination. So we want what is equivalent resistance and equivalent EMF in series combination. Let E1 comma E2 dot 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 B EMFs of n cells having internal resistances R1 comma R2 up to Rn connected in series as shown. This is positive, negative, one cell E1, internal resistance R. If I connect दूसरा cell का positive here, means negative is connected to positive, then it is called proper connection in series. उल्टा हो गया तो उसको बोलते हैं opposing. तो कभी कभी गलती से ऐसा भी होएगा. If one is not connected proper, तो ये दोनों का result will be different. So this will be internal resistance R2. This way dot 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 dot. We are having till En Rn connected in series. Series means same current will keep on flowing throughout.
Yes, sir.
इस डायग्राम समझ गया सबको? Plus minus plus minus plus minus, then it is called series combination. So what will be E equivalent? It will be E1 plus E2
Plus E2 plus En.
up to En. And what will be R equivalent? Can you tell? R1?
R1 plus R2 till Rn.
Yes, because they are in series. So mostly they will not ask theory, but numerical they can ask series combination. सबको समझ गया series combination how it is connected? Plus
Yes, sir.
minus
Yes, sir.
plus minus, resultant EMF is sum and resistance is also sum. Write this heading and draw diagram, copy till end. Your this Sunday's test will be on current electricity. Whatever I complete till Friday. That means indirectly it will be full theory. Okay. Tell me what is resultant EMF? Resultant EMF. Yes, Avan. What will be the answer of resultant EMF?
E1 plus E2.
E1 plus E2. And resultant resistance?
Choice of R1.
R1 plus R2.
Very good.
So there you have written R2. should be
Pardon?
written.
Pardon?
R2 should
Sir.
be written in there.
No, R1 plus R2. No?
Sir, in the
No,
diagram.
in the diagram.
R1 plus R2. This is called two cells assist each other. Two cells assist. That means they are helping each other. Two cells are assisting each other. Yeah. Now, two cells, if oppose each other, then minus is not connected with plus, minus is connected with minus. Now, can you tell what will be direction of current with E1 from E1, left or right? E1 वाला करंट किधर जाएगा? ऐसा जाएगा ना लेफ्ट में,
Yes, sir.
because current flows from positive. And E2 वाला करंट?
Right.
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 Are they in same direction?
No.
No.
So result will be difference or not?
Yes, sir.
When difference current difference होएगा, मतलब voltage भी difference ही होएगा ना, because current and voltage are directly proportional. Hello?
Yes, sir.
So whenever two cells are not connected assisting each other, series में तो है, but minus is not connected to plus, but they are connected minus minus together. Then we say they oppose each other. Now tell me, current Goel, what will be resultant EMF?
E2 minus E2.
E1 minus E2 or E2 minus E1. Both possibilities there. Difference. Here I have assumed that E1 is greater than E2. Mohit, can you tell what will be resultant resistance? Mohit? EMF we got E1 minus E2. Yes, Mohit, what will be resultant resistance? Resistance तो same आएगा ना, series में connected है. So don't think anything of resistance. It is R1 plus R2. Followed?
Yes, sir.
Mohit, you are able to hear? मोहित को लगता है विकेट डाउन है. So resultant resistance will be R1 plus R2, but please remember EMF will be different. Everybody has followed the concept of assist oppose.
Yes, sir.
Assist
Yes,
means
sir.
what is EMF? Plus. And oppose means what is EMF?
Minus.
And resistance will be same, series parallel वाला जो formula होता है. But can you suggest आपको क्या देख के समझ में आएगा assist है क्या oppose?
The direction of
Positive and negative
Positive,
signs.
negative sign.
Very good. When plus connected to minus and minus connected to plus, मतलब उल्टा टर्मिनल कनेक्टेड टुगेदर तो एडिशन होता है. देखो उल्टा है, माइनस प्लस उल्टा कनेक्ट हुआ है ना, माइनस प्लस, दिस माइनस is connected to plus, उल्टा connected है ना. Hello?
Yes, sir.
So whenever you see minus plus connected together, it should click in your mind, it is assisting. And when like terminal, then it is called opposing. Please copy this note, important for numerical. In textbook, opposing word they have not used, not shown, but generally it comes in the exam.
Done, sir.
Yeah? Okay. Can I clear this?
Yes.
Yes. Good. Now, next one. Derive expression for equivalent EMF and resistance when two cells are connected in parallel. When two cells are connected in parallel. I'm clearing this heading. I'm clearing this, correct? Heading हो गया?
Yes, sir.
So what you wrote after equivalent?
Equivalent
EMF.
EMF and resistance when two cells are connected in parallel. Derive expression for equivalent EMF and resistance when two cells are connected in parallel. See. Consider two cells of EMF E1, E2 having internal resistance R1, R2 to be connected in parallel as shown. To be connected in parallel as shown. E1 internal resistance R1, E2 internal resistance R2 connected in parallel between 2 points A and B. This all are same. This wire A, B all are same. So this much I think you will have followed. Connected between 2 points, 2 resistance in parallel. Parallel मतलब एक के नीचे एक. Plus I have shown together. वैसा minus भी हो सकता है. This much you have followed.
Yes, sir.
Yes, sir.
Now imagine E1 is giving current I1. तो E2 का करंट क्या लो? I2 बराबर. At this junction ये दोनों ऐड होके I हो जाएगा ना? हेलो?
Yes.
और इसको वायर से ज्वाइन कर दो तो इधर फिर से बी पे आई एंटर होके इट विल गेट डिवाइडेड इनटू इट्स रिस्पेक्टिव ब्रांच। आई होप सबको डायग्राम समझ गया है। सबको डायग्राम समझा?
Yes,
Yes,
sir.
sir.
देखो इसको अगर वायर से कनेक्ट करेंगे तो सेम करंट आई विल एंटर नो फ्रॉम हियर टू बी। नॉट फॉलोड?
Followed, sir.
Followed, sir.
Please write this much and draw diagram. Then we'll see what is equivalent resistance and EMF. Hello? Yeah? हाँ नहीं, पर कहाँ से बात कर रहे हैं पता है इससे? तो मुझे नहीं इंटरेस्ट है ये भुवनेश्वर से कम क्यों, मतलब मुझे नहीं इंटरेस्ट है ना, जरूरी है कि जो आप बोलेंगे मुझे उसको चाहिए। Yes, completed.
Yes, sir.
Yes, sir.
If I consider this point A, this point B, and here there is one battery with positive terminal, and this is that resistance R1. थोड़ा सा माइंड को शार्प करके बोलना, ए का वोल्टेज ज्यादा है क्या बी का वोल्टेज ज्यादा है?
Okay.
ए, बिकॉज वो पॉजिटिव के साथ कनेक्टेड है ना।
Yes, sir.
हाँ, तो इसका बीच का पोटेंशियल डिफरेंस, कैन आई से इट इज VA माइनस VB?
Yes, sir.
Because A is connected to positive terminal. Hello? Yeah. नहीं, मुझे एक सेकंड, मेरे पास टाइम नहीं मैडम। हेलो? हाँ, वन सेकंड ना, सॉरी। ए का वोल्टेज ज्यादा, बी का वोल्टेज कम, तो VA माइनस VB is potential drop across AB. Similarly, if I consider lower वाला branch with E2 and R2, now can you tell किसका वोल्टेज ज्यादा?
एक है।
हाँ, फिर से एक का बराबर। So for branch with battery of EMF, oh sorry, you have written everything na please?
Yes, sir.
Okay.
Yes, sir.
ठीक है। For branch with E1 VA minus VB, can I say battery is supplying the current, so E1 minus I1 R1 will be the potential drop. देखो आपको मैंने समझाया था, E is V plus IR when battery is supplying the current, so E minus IR will be V or not?
Yes, sir.
Yes, sir.
So ये हो गया VA minus VB is E1 minus I1 R1. That is potential difference V is E1 minus I1 R1. So can I say from this I1 R1 will be E1 minus V and I1 will be E1 minus V upon R1. I hope you followed.
Yes, sir.
Yes, sir.
Correct. One more formula for I2, but this time we will write similarly. Similarly, I2 equals to E2 minus V upon R2. This also second line clear.
Yes, sir.
Yes,
But,
sir.
but, what is total current? Is it I1 plus I2? है ना?
Yes, sir.
Main diagram से I1 plus I2. So I will become E1 minus V upon R1 plus E2 minus V upon R2. This also followed.
Yes, sir.
One more line. Can I say E1 upon R1 minus V upon R1? This is plus E2 upon R2 minus V upon R2. Any doubt?
No, sir.
So,
No, sir.
Please copy till there. First we have found I1, then we found I2, then total I is I1 plus I2. Swaraj, Sandesh, Aryan, Bagwe,
Yes, sir.
any
Yes.
doubt? See, any doubt, please keep on asking. Don't hesitate. Physics is not difficult if you clear your doubts, and very difficult if doubt is persisting. Once you complete, please tell, huh?
Done, sir.
So we got I1, we got I2, then we got I. Please wait 1 minute again. E1 upon R1 plus E2 upon R2, positive I am taking together, minus common V1 upon R1, V upon R1 plus V upon R2. This minus, if I bring on left side, it will become plus. I take on right side, it will become minus. So this is like ये पूरा V 1 upon R1 plus 1 upon R2 will become E1 upon R1 plus E2 upon R2 minus I. Any doubt?
No, sir.
No, sir.
Very good, very good, very good. So V is E1 upon R1, E2 upon R2 minus I. Throughout में I1 1 upon R1 plus 1 upon R2, 1 upon R1 plus 1 upon R2 से डिवाइड कर दिया. चलेगा ऐसा? समझ में आया क्या किया? ये पूरा
Yes, sir.
ब्रैकेट को डिवाइड कर दिया. चलेगा? समझ गया ना बराबर जैसा?
Yes, sir.
Just copy till this. Just copy till this. You are done?
Yes,
Yes,
sir.
sir.
Okay. Avan, you say. Avan? A battery is supplying current. Then what is terminal voltage V का formula? In terms of E, I and R I want. हाँ? एक सिंगल बैटरी जिसका EMF E is supplying current I, then what is terminal voltage V? No? Arya, you say?
E minus IR.
Very good. E minus IR. So I can say the same thing comparing with V equals to E. Now this E is E equivalent क्योंकि दो का रिजल्ट है. माइनस आई इंटू आर इक्विवेलेंट, दो का रिजल्ट है. वी गेट. नहीं समझ में आया लगता है. हेलो?
Yes, sir.
Yes, sir.
Everybody has followed this line which I wrote? V is E equivalent minus I into R equivalent.
Yes, sir.
Yes. So
Yes,
V
sir.
equals to therefore by comparing, can you tell what will be E equivalent? E1 upon R1 plus E2 upon R2, 1 upon R1 plus 1 upon R2. So whenever two cells are connected in parallel having internal resistance R1 R2, then their equivalent is E1 upon R1 plus E2 upon R2 divided by 1 upon R1 plus 1 upon R2. Okay, everybody has followed?
Yes, sir.
Good. First copy till this, then R equivalent also we are doing. This Sunday's test paper is going to be simple because current electricity is easy chapter.
Sir,
Yes, beta.
so you have corrected the Sunday's paper.
No, this Sunday's paper today I will correct.
Okay, sir.
By today night, you will get your answer key also and your mark also.
Okay, sir. Okay.
Actually, after this, 2 more papers I have to correct theory wala. Oh, because of that, I am waiting for writing your report card.
Okay, sir.
So mostly
Thank
ये week में सब हो जाएगा बराबर.
Okay, sir.
Yes. Any news about college opening or admission process starting?
No, sir.
Sir,
Huh?
sir, my friend told that he heard somewhere that it would be starting in this week.
In this week onwards, they will start.
It can start.
Acha, acha.
He heard somewhere.
Yes. I think it should start fast and finish off.
Yes, sir.
So far, we got only equivalent. Now, R equivalent also I have to find. Nandini,
Yes, sir.
what you studied yesterday?
So revised all the last lecture portion.
Say, don't leave rhythm of MCQ. If you don't have material, please tell me. I will send. But at least 10 MCQs minimum on daily basis. Don't leave it. Maximum is 50. Revising also you have done good job, but I feel MCQs also you should keep on revising, which we have done, because 2-3 बार करोगे ना तो याद रहेगा सर. So what we have done, you can again restart na from measurement, because completed till last slide.
Yes, sir.
Yes, sir.
Okay. लेफ्ट हैंड साइड वाला थोड़ा रब कर देता हूँ. नहीं सॉरी, इसके आगे ही बताता हूँ, रब नहीं तो समझेगा नहीं. सो बाय कंपेयरिंग, सी दिस वाज ई इक्विवेलेंट, ये पूरा ई इक्विवेलेंट है, और ये आर इक्विवेलेंट होएगा ना. हेलो,
Yes, sir.
this R equivalent is 1 upon all this, na? So can I say R equivalent is 1 upon R1 plus 1 upon R2? Okay.
Yes.
If you have followed this, then I'm just clearing this one line. If I cross multiply, then 1 upon R1 plus 1 upon R2 is 1 upon R equivalent I'm getting. ये पूरे को क्रॉस मल्टीप्लाई किया ऊपर. हाँ, is it parallel combinations का आंसर?
Yes, sir.
Yes. Resistance in parallel, 1 upon R equivalent is 1 upon R1 plus 1 upon R2, but EMF E1 upon R1 plus E1 upon R2, 1 upon R1 plus R2. Copy till this. Now, based on this one numerical, so that you get idea of parallel combinations, equivalent EMF and equivalent resistance. Done full?
Done, sir.
And question C. This is battery. of EMF 6 volt, internal resistance 1 ohm. This is another battery of EMF 3 volt, internal resistance 1 ohm. Find E equivalent, R equivalent. E equivalent, what is formula? E1 upon R1 plus E2 upon R2, 1 upon R1 plus 1 upon R2. Got it? This formula?
Yes, sir.
Now E1 is 6, R1 is 1, E2 is 3, R2 is 1, 1 upon 1 plus 1 upon 1. So that will become 6 plus 3, 9 upon 1, 2 upon 1. So can I say 9 upon 1 into 1 by 2, 4.5 volt. I hope you followed. Equivalent, you followed 4.5.
Yes, sir.
Yes, sir.
And then how to get R equivalent? 1 upon R equivalent, 1 upon 1 plus 1 upon 1. So 1 upon R equivalent is 2. Therefore, R equivalent will be 1 by 2. Okay. Yes, Kathan, followed this also?
Yes, sir.
Yeah, solve now. Draw diagram, this question part, then solution.
Done, sir.
Okay. Second one. Three. Three. E1, E2, R1, R2, E3 is 3 volt, R3 is 1 ohm. Find equivalent EMF between A and B. See, E1, E2 का equivalent I have written EQ1. then it is connected in series with that E3. So final equivalent will be EQ2 with R equivalent of second time. Diagram followed first. Concept of diagram followed.
Yes, sir.
ये दो का इक्विवेलेंट EQ, रेजिस्टेंस का REQ, फिर साथ में एक्स्ट्रा भी कनेक्टेड है ना, that will also add up now. So final it will become EQ equivalent in second case. E equivalent for second and R equivalent for second. Just draw these two diagrams. You have to find resultant E equivalent.
That V3 is equal to
E3 is 3 here, na? See, it's shown. E3 ऊपर लिखा है 3 volt.
V3.
हाँ, V3 नहीं है, R3 है. V3 नहीं है, R3 है. I got answer as 0. Let me see how many of you are getting. And resistance नहीं चाहिए, खाली equivalent EMF चाहिए मुझे. Hitarth, got the answer? Hitarth? Anay? Rajvardhan?
Yes, I got so.
What is the answer?
0.
0. Okay. I think equivalent of E1, E2 you got as 3, correct?
Yes, sir.
And this 3 and this 3 are opposing each other.
Yes, sir.
Therefore, result is 0. For E1, comma E2, E equivalent will be E1 upon R1 plus E2 upon R2, 1 upon R1 plus 1 upon R2. So E1 is 3 upon 1, 3 upon 1. This is 1 upon 1 plus 1 upon 1. So 3 and 3, 6 upon 1 plus 1, 2 by 1. So this will become 6 by 1 into 1 by 2. Therefore, E equivalent is 3 volt. Now for EQ1 and E3 in series, E equivalent in second case is EQ1 minus E3 because they are opposing. So 3 minus 3 answer 0. अभी समझा सबको ये कैसा है 0? Yes, Arya, Isha, Pranjali,
Yes,
Neha, everybody has followed.
yes, sir.
ये एंट्रेंस का फेवरेट है क्वेश्चन, बुक में नहीं है अपना. Now your homework is whatever I have completed today, please practice 2 times, otherwise you will forget everything. And MCQ of kinematics, the sheet which I have given 1 to 20 from the start. Once again you practice 1 to 20. Completed?
Yes, sir.
Yes, sir.
Yeah, one favor I want from you all. Can you write and post your timetable of lectures from for a week, that Monday, Tuesday, Wednesday, Thursday? I want to just check what is your schedule.
Yes.
Yes, sir.
If you get time, please do that favor for me. Monday से लेके Sunday तक का ना आपका लेक्चर का टाइमिंग पोस्ट कर दो प्लीज. हाँ, टाइम मिला तो 1 घंटे के बाद, 2 घंटे के बाद, शाम तक कभी तो प्लीज. हाँ,
Yes, sir.
okay, that's all for today. And Friday same time lecture we will try to complete now numerical theory completed of this chapter.